you're about to see how to use some sum to product formulas to solve a trig equation. So it's like exercise 16a. So what we're going to do, we're going to solve for x. I have sine 5x plus sine 3x equals 0. And previous to this, what we could have done is like substitute something in k for this, but this one over here is a different angle measurement, so we just can't do that. But we could just use a sum to product formula that would basically factor that left side. It'll be equal to 0, and then we can use the zero product property. Okay, so if you recall, the sine of 5x plus the sine of 3x, that is equal to, when I have the sum of sines, it is 2 times the sine of the average of them, so 5x plus 3x over 2, times the cosine of the difference divided by 2, so 5x minus 2x over 2, still equal to 0. Do some simplifying. So 2 sine, I have 5x plus 3x is 8x divided by 2 is 4x, times the cosine of 5x minus 2x is, well, y minus 2x. I'm going to go ahead and switch that to 3x because that's what the problem has. Okay, so 5x minus 3x is 2x divided by 2 is just x equals 0. Now I have a product of two things equal to 0. And it doesn't even matter that these are different angle measurements. Oh yeah, I have to deal with this 2 that's out here. How about I just divide both sides by 2 and get rid of it? So on the left half we have the sine of 4x equals 0 and the cosine of x equals 0. So remember this multiple angle, the way that we deal with it is think of it instead as the sine of k equals 0. So where is sine equal to 0? Looks like an asteroid hit my unit circle right there. Anyway, the sine of an angle is equal to 0 right here at 0 or at pi or at 2 pi, 3 pi. These are just multiples of pi. So k equals n pi. But I don't want k, I want 4x. Substitute that back in pi. Just divide both sides by 4, so x equals n pi over 4. There's all of those answers. Second one, where's cosine equals 0? Let's look back at this dented unit circle. That would be at pi over 2. Down here at 3 pi over 2, etc. Keep going around. So here x is equal to pi over 2, well, n pi over 2 is just multiples of that. But would you agree that if I have multiples of pi over 4, so like 0, because 0 times pi over 4 is 0, and then the first multiple is pi over 4, the second multiple is pi halves, and pi thirds, and then pi, and then 5 fourths, and then 3 halves. So it takes care of, this one takes care of all of those. So this one is redundant. So we don't need it.